Okay, hi everyone. I hope you can all see and hear me. Dimitri, if you could please verify that I am live. Okay, great. So, hi everyone. I am Giaglis. I'm the executive director of the Institute for the Future at the University of Nicosia in Cyprus, and this is the 10th session of our MOOC Introduction to Digital Currencies. Good evening to anyone that following us from Europe. Good morning to the people in the United States, and looking forward to today's session as well as the rest of the courses. As you know, we're turning the final corner of this course. You've done the first 9 courses with Andreas Antonopoulos and Antonis Polemitis, and the final 3 ones are going to be with me. Just a quick intro about myself. I'm seeing a comment that you're getting an echo. Uh, is that the case for everyone? Okay, great. Thanks. A bit of background for me. As I said, I'm a professor at the University of Nicosia for the past 3 years. I've been working on cryptocurrencies and blockchain since 2012. So I guess I was one of the first academics in the world to get into this area. I'm mostly interested in the algorithmic governance issues related to blockchain, things like decentralized autonomous organizations, tokenization and token economics, as well as issues related to the introduction of central bank digital currencies and other forms of new types of money in our world. The title of today's session is Industrial Applications of Blockchain. I'm going to be following a somewhat different path than my colleagues in the previous sessions, in the sense that I will be going over the slides, not necessarily doing the lecture. I would still assume that you have already seen the material and watched the material on Moodle, but I'm going to highlight the, let's say, most important points of what I would like the learning outcomes of this session to be. And please feel free to use the chat function on YouTube to ask any questions. Dimitris was kind enough to forward me some of the questions you have asked on the Moodle, so I will be taking them on as I go through the slides. Okay, so as I said, the subject of today's session is industrial applications of blockchain. In the past couple of weeks, you went through the financial applications of blockchain with Antonis, and this week we're going to turn our attention to the non-financial applications of distributed ledger technology. So I have 3 objectives from today's session. There are 3 things that I would like you to take away from this. The first is to take a step back from the technology itself and understand what is the reason that blockchains are considered so revolutionary. Why is this hype and whether it's worth it? And in order to do this, we will have a quick discussion on decentralization, and this is a discussion that we will elaborate on in more detail in the next week. Based on this discussion, we will focus our attention on the different application areas of blockchain and discuss what I personally think are the most interesting ones, but since there's no objective reality in what, as far as what the killer applications of blockchain will be, I think the most important part is to give you a framework in which you can think about blockchain applications and why some of them are going to be more disruptive than others in the future. And finally, we will explore a specific stream of applications, those that are based in what we call tokenization, i.e. the issuance of digital tokens on distributed ledgers that these tokens represent some type of non-blockchain real-world asset, and I will try to explain to you why I think this is a very interesting domain. So we'll go through these in sequence. So let's start by why is blockchain important and why is decentralization the main underlying principle behind it. We live in a world in which almost everything around us has been structured in a way that there are at least one, even more intermediaries in almost every type of transactions that we're doing, and no matter what you think of what application area, there's likely to be some sort of intermediary sorry, I'm seeing that some of you do not have a good visual. I hope that this is not the case with everyone. Things look good in my end in terms of internet speed. So Dimitri, let me know if there's something I can do to make this better. Anyway, if you cannot see the slides from the video, you should all have the slides in your Moodle platform already, so feel free to open the presentation there. As I said, in most application areas, there is some sort of intermediary that is controlling transactions or controlling what's happening there. And if you think, for example, the way the current financial system is structured, there are banks, and most people, simplistically think that we hold money with the banks. In reality, we hold only entries in bank ledgers that say how much money the bank owes us. We will get that money in real money, in cash, only when we withdraw that money from the bank, and we've seen time and again that there might be issues every time you have a centralized world. And the issues fall into three categories. First of all, when you have intermediaries in all sorts of transactions, they need to be trusted. However, they cannot always be trustworthy, either for reasons that have nothing to do with them. There might be, external attacks to centralized ledgers, or there might be internal corruption or a business failure in an organization. Most importantly, intermediaries, centralized record keepers, are also gatekeepers. They control who can participate in the system and what transactions can take place. So if you are a crypto startup, you might see that you might have problems with certain banks opening bank accounts because the bank acts as a gatekeeper in the system, and they might not want to have you as their customer. And if you are essentially shut out of the banking system, there's not much you can do because the system is controlled by these gatekeepers. Most importantly for me, these centralized gatekeepers can be single points of failure. This means that if something goes wrong with them, the whole system might collapse. You might have heard the term too big to fail for the banks in the financial crisis we saw about 10 years ago. So there are a number of reasons that we would like to have alternatives to our centralized world. And over the past 20 years, there has been a trend towards moving to a more decentralized world. The internet as we know it is the most well-known and widespread example of a decentralized system, in the sense that it is a system in which there's no central authority, there's no central owner, there's no central controller in the system that determines who can participate in it or not. It's a case of what we would call a permissionless system. You can go on the World Wide Web or set up an email account or whatever without needing to have anyone's permission if you have a telecommunications connection at least. Bitcoin and similar open permissionless based systems are a step further in this trend toward decentralization, in the sense that as the internet created a decentralized architecture for information exchange, Bitcoin and other platforms started creating over the past 10 years decentralized architectures for value exchange. And as we will see next week, this is a fundamentally disruptive and fundamentally revolutionary achievement. So what is important about decentralized systems? There are a number of advantages and a number of disadvantages associated with them. On the advantage front, these systems are peer-to-peer. So as I said, they are disintermediated systems. Transactions happen in them without intermediaries, and so we solve a number of problems that we have with centralized systems. The networks are also distributed in the sense that there's no central controller or owner. The network is the sum of its participants, so the Bitcoin network is literally the sum of the full nodes running the Bitcoin protocol. The internet is the sum of the peers running the TCP/IP protocol. There's no central authority managing the system. They're more reliable. They tend to be decentralized systems, tend to be more reliable because there's no single point of failure and there's a significant amount of replication. For example, in the case of Bitcoin, every single transaction is broadcast and stored independently in each and every full node in the system. So even if a large number of nodes become unavailable for whatever reason, the system still operates, something which is not the case, of course, with a centralized system. A very important characteristic is that these systems are censorship resistant, so there's no party controlling who can participate in the system and the flow of data that are exchanged in it. And there are a number of potential advantages. I've preceded each of them with a maybe clause, in the sense that these are not inherently attributes of decentralized system. You can design decentralized systems that have these characteristics or not. So you may have public decentralized systems in the sense that transactions may be available or verifiable by anyone, as is in the case of Bitcoin, but not necessarily in other systems. They might be permissionless, that anyone may be able to participate in the network, or there might be hardwired rules for who can participate. And they may be immutable, as is in the case of blockchain, in the sense that once a transaction is written, is recorded in the ledger, it cannot be altered or deleted in any way. Of course, decentralization is not only about advantages. There are specific disadvantages associated with decentralized systems. Two of them being security. In order for such systems to be trusted, you need to have the majority of participants being benevolent actors, so being actors that will not have an interest in attacking or otherwise compromising the system. Now I've put this in the disadvantage column, but if you think about it in more detail, one should compare it with the alternative. and the security of a system in which you need to trust the majority of participants is probably better than a system in which you need to trust only one participant, the one that is mediating the transactions. The second disadvantage of decentralized systems is scalability. Typically, these systems are not as scalable or as fast as their equivalent centralized systems because of the need to have all the replication that you need to embed in these systems. Now, with this discussion in mind, and again, we will elaborate a lot on this discussion during next week, let me turn into what is the focus of today's lecture, and is what are the most important industrial applications of blockchain. I have a quote here from Mark Andreessen, one of the first core developers of Bitcoin. It comes from 2014. I encourage everyone to read the full article as it appeared in the New York Times. I think it is one of the best articles in explaining at that very early stage what is so revolutionary about Bitcoin and why blockchain matters. I will not go into the details of the quote here. I will focus on this. There's a huge number of applications that can be built on blockchains, and in my mind these can be grouped into two main categories. The first category is what I call the boring stuff. Boring not in the sense that they are not important. We will see these types of applications, and some of them are going to make huge differences in their domains. But I consider them boring in the sense that they mostly will replicate what we are already doing, but moving it on a blockchain infrastructure. What I mean by this, it's quite typical in many cases when a new technological development happens that is of foundational nature. The first thing that people think about and the first thing that people do is move some of the stuff that we were doing in a previous infrastructure into a new infrastructure. So for example, when the internet first came about, people started thinking about, moving newspapers to the internet. And obviously having, the Financial Times on the internet is something, and it works, and we have it today. But I don't think there would be many people that would agree that, moving a newspaper or a bank online is something super revolutionary. It's something that brings some incremental improvements in some sort of key performance indicator, but the real revolution of the internet was the really native applications. The things like, social media or Airbnb or Netflix or whatever, or Uber, that couldn't have existed before the internet. And I put this in the second column, what I call the exciting stuff. And I think what we should focus our attention when we think about blockchain applications are those applications that I call native. Native applications in the sense that they enable things that couldn't have existed before the blockchain. I think these are the types of applications that are going to generate exponential improvements, order of magnitude improvements, and these are the ones that are going to unleash a new wave of creative destruction that will probably tilt the balance of power in the world of technology. As the internet, as we know it, created companies like, Google or Apple or Uber or Netflix, blockchain in the next few years, I am sure about that, is going to create new types of companies that are going to create huge added value and are going to displace some of the world's largest companies that exist in the technology world today. So if we were to think about what are these exciting new applications, what are the applications that are native to the blockchain, I think we can group them into 4 categories. One is decentralized finance, so moving the world of financial applications into a decentralized structure. The second one is what I call decentralized infrastructure, so creating new types of internet-based architectures that are decentralized in nature, what some people might call Web 3.0 or something like that. And based on these 2 things, based on a decentralized finance and decentralized internet architecture, we can start thinking about building decentralized organizations and decentralized markets. So the rest of the presentation is about these things. Let me start with the first one, decentralized finance or DeFi. It's a thing that has created huge interest, and rightly so, especially in the last few months, especially when it comes to markets that are using, or protocols or platforms that are using smart contracts in order to automate the process of matching borrowers to lenders and setting up algorithmically determined interest rates based on the ratio of borrowed to supplied assets in a market. I think that decentralized finance represents a true revolution in how the architecture of our existing financial systems is based on. And as I say in the second bullet there, I think that DeFi brings things like programmability into the world of financial applications. That is something that simply did not exist in a centralized architecture. Our ability to program how financial applications are behaving and program it even at the user level, at the level of the holder of the assets, is something that we haven't seen in the past. Interoperability, the ability to create what we call money Legos, so taking different applications and plugging them together to create even more sophisticated and advanced applications. Transparency, having all this into built in an architecture in which the software is open source, it can be viewed and reviewed and changed even by everyone, and self-custody in the sense that there's no intermediaries now, and we still retain ownership of the assets that we are contributing to these liquidity pools or other types of decentralized finance applications, is something that I think it's quite revolutionary, and we're going to see many applications of this in the future. For those that are a bit more philosophically inclined or want to think a little bit about more in the future, pay attention to the last slide there, because interestingly, decentralization has within it a seed of centralization as well. So think that what we're doing right now is that we are moving parts of the global financial industry on top of a common software infrastructure, which might now be the Ethereum virtual machine, but in reality this creates a situation in which decentralized applications will end up running on top of a centralized architecture again. So there's something to think about there. I mean, it's not really a centralized architecture because Ethereum is a decentralized system, but you know what I mean. I see a few people in the chat saying that the visuals are blurry for them. That's a real pity. They seem quite okay from my end. I think this might have to do with my bandwidth. We'll see what we can do. But as I said earlier, one quick workaround, if you cannot see the slides, is open the presentation from Moodle. It was already there. And if there are people that are watching this that are not MOOC students, Dimitri, if you could upload the PDF in the chat, that would be something that would help people. Sorry about that. We'll make sure that we'll work on it for the next version. So moving to the second domain of blockchain applications, and this is decentralized infrastructure. As I said, this is about building the next World Wide Web, or the next layer in the internet. We are moving, I think you have discussed this a lot with Andreas Antonopoulos in some of our earlier sessions. We are moving from today's Internet of Information to tomorrow's Internet of Value. In other words, we are moving to a decentralized architecture in which it's not bits and bytes that are flowing across the internet. Well, it is bits and bytes, but these bits and bytes do not represent informational notions only, but they represent actual monetary value. And this value is able now to move across the world without national borders, without intermediaries. And I can think of a number of advantages and a number of disadvantages based on this, but in any case, this is a revolutionary thing. It's going to change the way that much of our world operates if we are able to have capital move frictionlessly and efficiently across the world to find the best opportunities. It's not only money though. The Internet of Value is also about disrupting the way that the Internet itself is being built. There are a number of interesting applications of blockchain in decentralizing aspects of the core Internet architecture, like the domain name service protocol and having a decentralized DNS provision. Check companies like Blockstack, for example, as examples of companies building the next version of the web. The second type of application that I think is of great interest when it comes to decentralizing our infrastructure is what we call self-sovereign identities. And self-sovereign identities is a way of trying to solve the problem of identity theft or identity verification on the internet. That is a big source of problems in our current internet. And blockchain is capable of decentralizing the architecture of identity verification by creating digitally signed credentials that can be verified without the presence of intermediaries. There are a huge number of applications around self-sovereign identities, from the very basic that have to do with decentralized verification of online credentials. At the University of Nicosia, our first spin-off company from the Institute for the Future that I'm heading is Blockco, which is a company that is doing exactly that when it comes to academic degrees or digital credentials of any source. So those of you that are going to be finishing the MOOC, you're going to receive a blockchain verifiable certificate for your participation in this course, and this certificate will be self-validated. So you will be able, anyone that is presented with this certificate will be able to validate its authenticity without having to to contact the University of Nicosia or anyone else. The application of self-sovereign identities is very interesting in the sense that many people think that what we are trying to solve here is how we identify humans. So, which obviously falls under the boring versus exciting dichotomy that I said earlier. What I mean here is the following. You could obviously verify humans, so verify that George Giaglis is indeed George Giaglis using a better type of verification mechanism than the ones available today on the internet. And this is surely an interesting application of blockchain. However, as we will see in the last week of our course, in week 12, the future is about convergence of blockchain with other technologies. And one of these technologies is the Internet of Things. We live in a world in which many billions of objects are being connected to the internet, creating a parallel architecture in which the TCP/IP enabled machines are not machines that are being operated by humans, but are machines that operate autonomously with the help of sensors on an internet architecture. So it's, I think, and we will discuss it more in week 12, that we will see a world in which self-sovereign identities are going to be used for verifying the identities of objects and machines in ways that simply do not exist today, and ways in which couldn't have been possible before the invention of blockchains. Again, I'm seeing in the chat that people are saying that it might be a setting on my end. So if you would allow me, just give me 1 second to check if there's something that would that changed since the time we did the test earlier with Dimitris, because nothing was blurry there. Just give me 1 moment. Okay, let me try now and see if things work better. Moving to the next slide. Now Dimitris is telling me that this is now even worse. Yep. I think it didn't work, so let me try something else. No. Okay, I switched to a different setting. I'm not sure whether this works now. No, sorry everyone, it's not working. Let me close this and reopen. Okay, I hope it has become a bit better for you. If not, I'm really sorry for that. There's not much I can do at this point in time. And because I don't see your chat now, let me go through the slides and then we'll get to your questions. So the third application area is decentralized organizations, and this is about building a new type of economy. Our businesses today are still can still trace their roots to the industrial organization that came as a result of the Industrial Revolution. The the uh, uh, the blockchain is creating a wholly new architecture for restructuring our organizations towards more ad hoc, spontaneous, algorithmically governed forms. And decentralized autonomous organizations, or DAOs, are a very interesting application area. We'll discuss it in more details next week. But also institutional aspects of our economy, like voting, or making sure that we are, let's say, able to do a number of due diligence or compliance functions on disintermediated architectures, is another hugely important application area of blockchain. Finally, the last one is about decentralizing our markets and decentralizing the commerce of the future. We see a number of important applications coming up lately, like data markets or prediction markets, where transactions can happen in areas that were not commercially exploited up to now. So, for example, there's this huge discussion about whether the big tech companies like, I don't know, Facebook, are making billions on our personal data because data markets do not exist and users cannot monetize their own personal data in social media platforms. Well, blockchain creates mechanisms through which such data markets can be built, and I'm sure that in the next few years we will see a number of examples, some of them being hugely successful commercially, that would be built on this premise. I'm not gonna focus on the details of the slides, as I said, because first of all, you cannot read them well, and then they will be available on, they are already available on the Moodle. But I would like to finish this part of the presentation by saying that my prediction is that the future of commerce is not going to be distinguished between B2B or B2C commerce like we used to have in the early days of the internet, so business to business or business to consumer. The future of the commerce is going to be mostly machine to machine, or in some cases human to machine, and we will explore this in more detail in the last session of this course, when we're going to discuss how blockchain converges with other technologies like artificial intelligence and the Internet of Things. I would like to finish this discussion with a quick round on tokenization and take some of your questions within it. You can think of everything that has been happening on blockchain up to now as a road towards tokenization, and this diagram, I think, summarizes this. What I mean by this diagram is the following. We started with Bitcoin back in 2009, and Bitcoin can be thought of as the first example of a system in which a blockchain had its own native token. And I would like to take a moment here because one of the student questions on the forum was about the difference between native and non-native tokens. A native token is a token that exists on a blockchain and derives its value solely from its presence on the blockchain. So Bitcoin as a token exists on the Bitcoin blockchain. It does not represent anything else in the real world. So its value comes solely from its presence on the blockchain. And in the beginning, Satoshi Nakamoto captured the idea of incentivizing participants to validate transactions that are happening on a decentralized system and created Bitcoin as the only token that could be moved around in its native blockchain. So when people realized that this is something that has value and there could be either other applications for that, they started creating other blockchains. So what we saw in 2010 and 2011 was this explosion of altcoins where people were taking the Bitcoin code base, forking it, changing some parameters and creating, I don't know, Litecoin or other platforms that were basically forks of Bitcoin. And suddenly we created hundreds, if not thousands, of different blockchains, each one having their own native token. So there was only Bitcoin that could trade on the Bitcoin blockchain. There was only Litecoin on the Litecoin blockchain. There was only Peercoin on the Peercoin blockchain. And then people thought, come on, this cannot go anywhere. Why not return to the Bitcoin blockchain and start building non-native tokens on it? Not really building these tokens because you couldn't actually build other tokens on the Bitcoin blockchain, but people thought of the following. Why not take one particular Bitcoin or one particular token, it could be a Satoshi or whatever, and say that this particular token does not represent a Bitcoin anymore. It represents, I don't know, 100 shares of Apple. And this gave rise to the idea of colored coins that Rahul is asking about in the chat. So colored coins were the idea that you could take something which was a native token on a blockchain, like a Bitcoin, and color it, not literally of course, figuratively color it so that it represents something else. And you would agree with each other that whoever holds this token holds in reality 100 shares of Apple that exist somewhere outside the blockchain. And this gave rise to the idea of non-native tokens. And this is the, if you want, the one of the reasons that platforms like Ethereum came about. Because Ethereum was a huge milestone in the history of blockchain because it became the first, at least the first widely adopted platform that combined both a native token, so there's a token called Ether that is the equivalent of Bitcoin on the Bitcoin blockchain, but on top of Ether, you can trivially create other non-native tokens like an ERC20 token or ERC721 for non-fungible tokens that could represent anything that holders of this token agree about. So instead of coloring Ether, you now create other tokens that do not need their own blockchain, so they don't, each of them does not have their native blockchain. All of them work on top of the Ethereum blockchain. And that's the idea of non-native tokens. And this gave rise to what we saw from 2017 until now, which was this ICO craze, and then we moved to the security token offerings and the initial exchange offerings, and regardless how you name it, we saw this explosion of tokenization. Rahul is also asking, what are NFTs? NFTs meaning non-fungible tokens. There is a concept in currency theory that is called fungibility. And fungibility has to do with the equivalence between two different tokens. So let's say, for example, that I have a 10 euro note and you have a 10 euro note. If we exchange these notes, nothing has happened in reality. These euros are totally fungible. You can exchange one with another, and there is no difference whether I'm holding this particular note or that particular note. In any case, I'm still holding 10 euros worth of money. This is not the case with other tokens. Even Bitcoin, it is not necessarily as fungible as is the US dollar or the euro, in the sense that each particular Bitcoin carries with it its whole history since the time it was minted. So from the time that it was created in a code-based transaction on the Bitcoin blockchain, every movement of that particular Bitcoin or part of a Bitcoin is being recorded on the blockchain. So no Bitcoin is 100% equivalent to each other, in the sense that some of them might be dirtier or cleaner than others, in the sense that, you know, if I come across and I'm the owner of a Bitcoin that was used in a, you know, Silk Road transaction or whatever, then this Bitcoin might be tainted for life. In other tokens, like for example, when we create a token that represents fractional ownership of a property, as I say in the next few slides that unfortunately we're not going to see, like for example in real estate tokenization. So each token represents ownership of a particular commercial or residential property, so it's very different from its neighbor token. So one token representing ownership of this house, another token representing ownership of a totally different house, and these tokens are not exchangeable with each other. They are what we call non-fungible tokens. Rich is asking, is this like someone writing on a dollar bill? Yes and no, in the sense that yes, when you write on a dollar bill, this dollar bill is somehow different from other dollar bills, and no, in the sense that even if it is different, it still has the same value, unless you write something that, I don't know, is something written by the US government that invalidates the dollar or makes it, you know, part of a criminal investigation or some other, you know, suspicious activity. It still retains its value, so you could pay with that dollar bill as you would with anyone else. But yes, if each US dollar had a specific code written on it, and this specific code could be looked at a registry, and you would see if this dollar was at some point part of a drug dealing transaction or money laundering or terrorism financing or whatever, then this becomes now a non-fungible token. Rahul is asking about the colored, Mehul, sorry, is asking about the color coins again. So let me elaborate on that, even if only for historical reasons, because what I'm trying to do in this slide is explain how blockchain has evolved over the years from Bitcoin to the world of tokenization that we see today. And part of this history were colored coins, but it's not part of the history anymore. But let's return into 2012, 2013. And let's imagine for the moment that we do not have any other blockchain but Bitcoin, or in general blockchains that are not like Ethereum. They are blockchains that each of them has only one token on them, and this is their native token. And you want to use the Bitcoin blockchain to create a functionality that would allow you to tokenize Bitcoin. So you take 10 Bitcoins aside and say, okay guys, these 10 Bitcoins now, this particular 10 Bitcoins that are stored in these addresses, these UTXOs I mean, we will now agree between us that they will not only represent Bitcoins and have the Bitcoin value, but they will represent something else, like the ownership of a house, a car, some stock, or whatever. In effect, what we are doing is that we are coloring these particular Bitcoins to represent something else. Now, some of you will wonder, and very rightly so, if we color these Bitcoins, color, again figuratively speaking, doesn't this require an agreement that cannot be enforced within the blockchain? So we will need a trusted third party to actually verify and enforce that whoever has this particular Bitcoin actually has ownership of that house or car or whatever. And you will be 100% right. As we will be discussing in the next couple of weeks, one of the problems of decentralization and tokenization, or rather not a problem, one of the characteristics of these systems is that you will always need intermediaries in order to enforce things that are happening outside the blockchain. Rahul is saying, if I tokenize a painting hanging on my wall, would that be an example of an NFT? An NFT? Yes, 100%. This would be something that would be a non-fungible token. So we have one token that represents ownership of that painting. However, what happens if Rahul sells me this token? So I pay an amount of money and now I hold this token. And then when I go to Rahul's house and say, okay, Rahul, now I would like to have the actual painting as well, please, because I would like to hang it on my wall. And Rahul then says, no, George, I'm sorry, I will not be giving you this, sue me. We will need some sort of intermediation because someone, and this cannot be done on the blockchain, would need to enforce my rights by holding the digital token as having access and ownership of the physical asset as well. So this is a very important distinction that people need to make between purely decentralized, 100% decentralized systems like, I don't know, Bitcoin, and not 100% decentralized systems like tokenized physical assets. There is a question by Irina who asks, does the history of a Bitcoin affect its price? That's a very, very good question. Again, yes and no. No, in the sense that there is no mechanism at the moment that would actually forbid me from taking a tainted Bitcoin, a Bitcoin that has been used in a criminal activity, some ransomware attack, for example, and is probably the result of that criminal activity, and not selling it on an exchange for whatever other Bitcoins are worth. So in technical terms, the history of that Bitcoin will not affect its price. What it probably will affect is the following though. If some law enforcement agency monitors, and they do monitor, the movement of Bitcoins known to have been used in criminal activities. And I suddenly present this Bitcoin on an exchange and sell it for whatever other Bitcoins are priced, it's more than likely that the next day the police is going to come knocking on my door and arresting me, or at least making me explain how this particular Bitcoin came into my possession. So there is a thing that is not as easily seen in fiat cash, in which, you know, I could spend my illicitly gained dollars on a shop or casino or whatever, and most probably nobody would be able to trace them back to me. You cannot spend digital currency, or at least most of digital currency, with the same ability to get away from the eye of the law. And this is a good thing in my perspective, at least. Rahul is asking if a non-fungible token is applicable to a collectible only. Not necessarily. It could be applicable to a number of things. So, for example, as I explained in the slides that follow the one that you are seeing now, you might have applications of tokenization that extend the spectrum of investable assets. So, for example, one of my favorite investable assets of the future is future itself, is future incomes, as I explained in the slides. So, if you invest in the future income of an athlete or a student or an artist or whatever, and you get tokens that represent rights to parts of their future income, you have a non-fungible token, because this token is tied to the income of one particular person. So it's not the same as its next door token, which might be let's say mirrored or tied to another person. But obviously these are not collectibles. It's things that are not exchangeable with each other at the same value. Gregor is saying that freshly minted Bitcoin could potentially be worth more if you can purchase over the counter. Yes, that's true. It has been proposed that, you know, fresher Bitcoins might be worth more than earlier ones, because simply they didn't have the opportunity to be involved in suspicious activities. But also the opposite might be true. So if I was able to get possession of the 50 Bitcoin of the first ever block, so the ones that were part of block number 1, because I think the Genesis blocks Bitcoins are not spendable, these will have a collector's value, because they are very, very specific. They were the first Bitcoins to ever exist. So even though technically they should be worth the same as every other Bitcoin, I'm sure that if I could auction them, they would fetch much more money. Or I've been talking about tainted money only. There's the opposite. There's money that can be sold from a demonstrably clean source. You might remember, or you might have heard, that I think it was in 2013 or 2014 that the US government auctioned a large number of Bitcoins that were confiscated by, I think, their raid on Silk Road. And I think it was Tim Draper that bought those Bitcoins in this auction that was done by the US federal government. Now, obviously, these Bitcoins are 100% clean, because you can demonstrate that you got them from the US government, and this is why in the auction these Bitcoins managed to fetch a price that was higher than the market price of that point. Let me see. Thank you very much for your comments on the chat. They are very, very good. Nishad is saying, would an NFT be like creating a digital currency with a total supply cap of one? Interesting question. Yes and no again. You could do that. So you could say that, okay, I will create a token that will represent ownership in Rahul's painting. So there's one painting there, so I will create one token. Or you might think that tokenization, as again explained in the slides, one of its biggest advantages is the concept of fractional ownership. So in that case, you might create a token that has a total supply of, I don't know, 1 million tokens, the total supply of which represents ownership of that particular painting. So if I hold one token, I am the owner of 1 millionth of that painting. Like now, if I'm an owner of one stock of Tesla, I'm the owner of one, I don't know how many billionths of the company, since the company has so many billions of shares floating. There is a question from one of the students to Dimitris. I don't know if he has answered it in the chat, but it's a good one in the sense that it's a technical one, saying that he doesn't know where the pre-class questions forum is. What I would suggest to everyone of the students, both in the MOOC and the MSA, is use the Moodle discussion forum. So if you go to the discussion forum and you will see that there is a dedicated space there for the live session questions, but even if you just open a different thread and say, guys, I studied the slides of session 10, and you can do this even after today's session, but I don't understand what it says in slide 34, please explain, then I will be happy to discuss it with you on the forum. Let me see your other questions. There was a question regarding whether the history of development is somehow associated with the price. And I don't know whether this question was informed by the slide, but let me just show you this. You obviously cannot read the details, but they're not important. What is important is that if you compare the development of Bitcoin, altcoins, colored coins, smart contracts, and ICOs of the previous slide, with the price of Bitcoin as a proxy of the, let's say, total market capitalization of the digital currency space in general, you will notice something that I personally find very interesting. There are periods of lots of activity in the space and lots of innovation happening, and usually these periods are not accompanied by a price appreciation at the same time. So when Bitcoin was actually being developed and the whole core protocol was being developed in 2009, 2010, Bitcoin was totally useless. Its price was literally zero, or a few cents at the best case. In the periods where we have huge price appreciation, and we have seen at least 3 cycles up to now, the one in 2011, one in 2013, and the last one in 2017, culminating in the tops that you see in this diagram. It's very interesting that these are usually the periods where there's not much innovation activity actually happening in the space. It may be because everyone is chasing appreciating prices and they're trying to make money, but for me it's interesting that the real developments, be that I don't know, with Bitcoin or with Ethereum or with the tokenization space, have largely happened in periods where the prices were dropping. So the price winters are innovation summers for me, and this is an interesting thing. I don't know if it's a coincidence or not. I see the last. Sorry, I cannot keep track with all the discussion in the chat, but there's a very interesting question by Nisha. See there. What about a non-fungible token that is the art itself, which is a very, very, very interesting thing to discuss. Up to now, I've mentioned non-fungible tokens that represent something that exists in the non-blockchain world, like, I don't know, income of a okay, now I think that the connection is lost. Dimitri? Dimitri, can you let me know if you can still hear me? Hello? Okay, I don't know if I can still being heard. In any case, we are beyond our allotted time, so I will finish here. I would like to apologize for the not good connection. I will make sure that I will work with Dimitri so that we do not have this in the next two sessions. Again, my apologies. Please feel free to follow up on the Moodle with your questions. I'll be happy to take them there, and perhaps we can do a separate session at some point if there are a number of questions and we cannot work on them in writing. So with that, thank you very much for your patience today. Hope you found it interesting, and looking forward to seeing you next week. Next week we're going to discuss